Hello friends, welcome to engineering tutorial. So we'll continue our discussion on thermodynamics. Previously we discussed some basic concepts related to thermal conduction, variable state and steady state in thermal conduction, temperature gradient, and also we discussed the various factors which come into play in heat flow or thermal conduction from one point to another point. In this video we are going to discuss about the concept of heat current and thermal resistance, again related to thermal conduction. So we have already discussed that thermal conduction, that is the amount of heat which flows from one point to another point, it can be expressed as this, where it is directly proportional to the area, directly proportional to the temperature difference between the 2 points, directly proportional to the time duration T for which the heat flow takes place, and inversely proportional to the separation distance between the two faces. So this is heat flow, and it can also be represented as this. Q is equal to K dt by dx into T. Actually it is represented as a minus here, and negative sign also comes into play because here as we move from the hot phase to the cold phase in the direction of heat flow, temperature is decreasing. Temperature gradient will be negative. So that's why it is minus Ka dt by dx into T. The minus sign only, it highlights the fact that as we are moving in the direction of heat flow, temperature is decreasing with respect to distance. Okay, that. Now, what is heat current? Now here we are all aware with the basic concepts of electrical circuits. There I am trying to give you a correlation between electrical circuits and thermodynamics. We know electrical current I is charge flowing per unit time. Okay, charge flowing per unit time. Okay, so here ampere, 1 ampere, which is 1 coulomb per second. Charge, which is in coulomb, time, which is in seconds. Charge flowing for unit time. So here in thermodynamics, heat flow is equivalent to charge. Okay, charge flow. Okay, in thermodynamics, this is electrical circuits. Then electrical current here is analogous to heat current. So if charge flowing per unit time is electrical current, then heat flowing per unit time will be heat current. So heat current is the rate of flow of heat, or heat flowing per unit time. That is the definition of heat current. So simply heat current is represented by H, which is equal to Q by T, or in differential form or derivative form it is dQ by dt. So here Q is in joules, time is in seconds, so joule per second or watt. That is the unit of heat current. So we know that Q is equal to Ka dt by dx into T, or minus Ka dt by dx into T. So we can represent heat current as H is equal to dQ by dt, which is equal to minus K dt by dx, or minus K delta T by delta x. This is the expression of heat current. Okay. So always remember the negative sign, it only indicates that as we are moving from the hot side to the cold side, the temperature is dropping down, it is decreasing. that is only the meaning of the negative sign. So that is heat current. Then also in electrical circuits we have the concept of electrical resistance. Okay, electrical resistance, which is the opposition to the flow of charge or the flow of electric current. So that is equal to potential difference divided by current. Electrical resistance is equal to potential difference divided by current. Here we have the analogous concept of electrical resistance in thermodynamics, which is called as thermal resistance. Okay, thermal resistance. So thermal resistance is basically the opposition to heat flow. Okay, it is the opposition to heat flow. So here thermal resistance, that can be expressed as potential difference by electrical current. So thermal resistance, it is represented as R subscript H, thermal resistance, that is equal to temperature difference divided by heat current, delta T by H. That is thermal resistance. It is the ratio of the temperature difference between the two ends of the conductor to the heat current flowing through it. Okay, it is expressed as this. RH is equal to delta T by H. Okay, this. Now we know that Q is equal to Ka delta T by del X into T, and H is equal to Q by T, that is equal to Ka delta T by del X. So if we substitute this value of H here, so we will have RH is equal to delta T by Ka delta T by del X. So here delta T will get cancelled, so we'll have delta X by Ka. Delta X will go into the numerator, and the thermal resistance RH will be equal to delta X by Ka. Okay, so here the unit is Kelvin per watt, because the unit of temperature difference, that is the Kelvin, and heat current, it has the unit of watt, which is joule per second. Okay, heat current here, the unit of that is joule per second or watt, and the unit of temperature difference, that is Kelvin. So Kelvin per watt, the SI unit of thermal resistance. The SI unit of electrical resistance, that is ohm. So this is the interesting analogous relationship between electrical circuits and thermodynamics, where charge flow is similar to heat flow, electrical current is similar to heat current, and electrical resistance is similar to thermal resistance. Okay, electrical resistance and thermal resistance. So whenever you have any confusion, you can use this correlation to clear your concepts. Okay, so here we have discussed about the concept of heat current and thermal resistance. So friends, I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.